Assalamu alaikum everyone and welcome back. Today we'll be exploring insertion sort, a simple yet powerful sorting technique that works very differently from the bubble sort we discussed earlier. Let's start with a scenario. Imagine we have a highway camera that captures vehicle number plates, which are in the format XXX-NNN, where XXX is some kind of an alphabet while NNN is some kind of an integer. Now, cars keep arriving and we want the plates to always remain in sorted order. Now, if we use bubble sort, we'd have to wait until we have the entire dataset before sorting. But in a live feed, we do not have that luxury. Wouldn't it be better if we could, let's say, keep the list sorted at all times as new data arrives? Here's how we can achieve that. When a new plate arrives, compare it with plates from the end of the sorted list. Keep shifting plates to the right until we find the right position. Insert the new plate there. This way, at any given time, our list remains sorted without having to rerun a full sort from scratch. Now let's walk through an example. We start with some set of plates: ABC 123, BGT 432, CDE 221, FGT 982. Now a new plate arrives, BAA 556. We compare it from the end. First, compare it with FGT. Move it one step right. Compare it with CDE. Move it right again. Compare it with BGT again. Move it right. Now we have found the correct spot just after ABC 123. Now the updated list will have ABC 123 at the first, then BAA 556, then BGT 432, then CDE 221, and then FGT 982. And just like that, the list is still sorted. This is insertion sort in action. While there are still unsorted elements, find the insertion point in the sorted portion, usually with a linear search. Shift all the elements after that position one place to the right. Then insert the new element. However, there is a catch. In contiguous memory structures like arrays, shifting multiple elements can be costly. And fixed size structures can't grow without resizing. This means insertion sort is best suited for small datasets or data structures that can grow and shrink easily, like linked lists or dynamic arrays. Let's take another dataset right over here. We sort these one at a time, inserting each into the correct position in sorted section. Here, the fourth iteration is shown. By this point, the first four elements are in order, and we are inserting the next number into its right position. Now it's your turn. Use insertion sort to arrange the following numbers: 8, 3, 5, 2, -1, 7,000, and 400. Remember, at each step, take the next number, find its correct place in the sorted section, shift others, and insert it. Now, before we finish, let's summarize the key characteristics of insertion sort. It works by growing a sorted list one element at a time. It is efficient for small datasets or nearly sorted data. However, for large datasets, the repeated shifting makes it slower than advanced algorithms. And that wraps up our discussion on insertion sort. It's simple to implement, keeps data sorted as it arrives, and is a great choice in the right context. Thank you. And as always, keep practicing.